Okay, question 1. We're looking at a thermometer, supposedly, and we say what we want to show what's the measurement to the correct precision. So we're going to see, well, this is 20, and each line means something. So 21, 22, so here's 25, here's 26. It looks like it's between 26 and 27, and so the proper thing to do is to go one more place, and so we're looking for 26 point something as our answer. And so that's the best answer, C, 26.3. Okay, when you see the number here, 0.0200 grams, has how many significant figures? Remember, zeros at the front of a number do not count as significant figures. Zeros after with a decimal point do count as significant figures because they're only there to show that that's how carefully that measurement's been done. So answer B3. Scientific notation, okay, so it's going to be 3.02. Okay, and then we say, okay, we have 1, 2, 3, 4, 5, 6. So it's times 10 to the 6th. Okay, so if this guy is bigger than 1, which it is, then it's going to have an exponent that's positive. If it was like 0.00003, it would be a negative exponent. So we're looking for 3.02 times 10 to the 6th. It looks like answer A. Which value is the same as this guy? Okay, 10 to the minus 3 means this thing is smaller, this number is smaller than 1, so we're going to move the decimal 3 times, so we're going to have point 0.00152. That was 1, 2, 3. Move the decimal point 3 times. So we're looking at answer B. Okay, number 5. How should the following computation be recorded? Okay, well, it's really not a math problem because these answers are all kind of, similar. What it really is how many significant figures should be in this answer. And so this number has 3, this number has 3, this number has 3, this number has 4. So we want an answer with 3 significant figures. And so we can eliminate that has 4, eliminate that has 2. And I guess it really is a math problem. We have to decide, is it the first answer or the last answer? And without calculating, I'm going to guess the first answer because 3 of these are all less than 1, one's greater than 1. And so is it going to be less than 1? Since I'm dividing by 315, okay, that definitely is going to mean my answer is going to be much smaller than 1. So answer A is the right answer. Number 6, here's that target, okay? So this person is not, very precise, not very precise in terms of being very consistent. So they're not precise, but they're also not very accurate. And for accurate in this case, we have to look at the group of them. So this guy, this guy, this guy, this guy. If we average the whole thing, we would end up somewhere over here, which is not accurate. So these guys neither accurate nor precise. Enter D. Okay, if it was accurate, it might be if they did something where they were all centered on the center, okay, then we could say it's accurate, but not precise. But these guys not accurate or precise. Okay, which is the most precise? We're looking for the smallest plus or minus. Okay, the bigger plus or minus, the less precise it is. So we want a small one, so this is B. That's the most precise answer. Okay, a density problem. Density is known to be 8.96 grams per milliliter. A student's result shows that the density was 8.79. Oh, what's percent error? Okay, so percent error. This is a formula you just have to have in your head. Okay, and it's just simply how far are we off? So I'm going to say 8.96 minus 8.79 and divide by what it's supposed to be. So it's supposed to be 8.96. So how far is it off? Okay, absolute value divided by what it's supposed to be times 100. And for answer 8, that comes out to be C, 1.9%. 9, which of the following is a measure of length? Okay, cubic centimeters, okay, that's going to be a volume. Okay, decimeters, that's a length. Kilograms, that's mass. Milliliters, that's volume. So decimeters is a length. It's about 1/10. It's about that long. 1/10 of a meter. I'm not sure that's right. Okay, the average of temperature on Venus is 460. What's this in Kelvin? Okay, Kelvin is always higher than Celsius. So I'm going to take my Celsius. I'm going to add 273. And that'll give me my Kelvin. value. And so what's there? So 460 plus 273, this is the only one that's a good answer. I don't even have to calculate it. Okay, which of the following statements is true? Is it true that there's 1,000 centimeters in a meter? No, there's only 100 centimeters in a meter. Is it true that a millimeter is a hundredth of it? No, that's centi. Kilogram is 1,000 grams, that's it. And each of the statements is true, no. What conversion factor would you convert from feet to inches? So if I started with feet, and then I wanted to change feet to inches, I would put feet on bottom, inches on top, and I know for every 1 foot there's 12 inches. So I'm looking for an answer like that. 12 inches over 1 foot, answer C. 13. What conversion factor would you use to convert milligrams to grams? Okay, if I was starting with milligrams, and I want to go to grams, then I want milligrams on the bottom, I want grams on top, and for every 1 gram there's 1,000 milligrams, so I want 1 over 1,000, 1 gram over 1,000 milligrams. Here's answer B. Now notice also what I've been doing the last couple of questions, and that is when I get a question, then go ahead and figure out what the answer is. Don't look at the answers. Don't try to pick out which answer is right. Just go through and do the question and answer the question, and then look for that answer in the answers. You know, and then that way, then you're not misled by some of these questions. Some of them, you know, then that looks right, and that's not what you want to do. Okay, a metal cube measures 2 metal cube. Okay, so a cube means that I have a perfectly little square deal. Every side is 2 centimeters. Okay, so its mass is 90.4. What is the metal? Okay, what is the metal? I know the densities, so I got to figure out the density. Now, density is equal to mass over volume. Okay, and the mass is given. That's 90.4 grams. Now, what's the volume? Okay, this is a cube, so it's 2 times 2 times 2, and 2 times 2 times 2 is 8 centimeters. Okay, but it's centimeters times centimeters times centimeters, so it's 8 centimeters cubed. So I'm looking for something that's 90 over 8. Okay, well, if this was 80, that would be 10, so it's a little bit bigger than 10. So I can see my answer is going to be D, 11.3. Okay, what is the volume of a 5.08 gram sample of liquid bromine, the density? Okay, density can be used as a conversion factor, and so I can say 5.08 grams, and I can say grams per milliliter. So there's 3.10 grams per milliliter. So grams drops out. So 5.08 divided by 3.10. So that looks like it's going to be 1 point something. Okay, so my answer would be B. Okay, the other way I can do this is say, okay, I can use my density triangle. Okay, so density is mass over volume, and I am trying to find the volume. So if I want my volume is equal to mass over density, so I can take my mass, 5.08, divided by my density, 3.10, and I get that same answer. Okay, this one. So 2 different ways, that a density can be a conversion factor, or we can do it as an equation using the density triangle, ISA. Okay, 16. A gold block and a copper block have mass of 5, which occupies a greater volume. Okay, well the density, is more stuff per volume. More stuff per volume. So we would say, well, which of these is a greater volume? So which one has, more stuff in my volume would make it smaller. So a gold block, okay, and copper, okay, density, gold is 19.3, copper is that, so gold is much more dense, can have much more mass per volume. So 5 kilograms of each one, gold would be a little guy, okay, and copper would be a big guy. Alrighty, so who's going to be a greater volume? My copper. Okay, so the copper block. Number 17, here's an atom. Okay, we've seen these. 27 protons, neutrons, and electrons. So we have to use our periodic table. We have a periodic table on the test. Okay, so we're going to look up cobalt, and I'll look up on my periodic table without showing you. Cobalt is number 27. Okay, in fact, if I look at this, it looks like cobalt. It has 27 on top. It has 55.85 on the bottom. Okay, so 27 protons, so I can definitely eliminate that answer. Now I have cobalt that weighs 57. Okay, so 57 up here, 27 here. So if I subtract those two, that's 30. Okay, that means it must have 30 neutrons. 30 neutrons, so I can eliminate this one. Okay, now for electrons, it has a +3 charge. Okay, well I know I have 27 protons. Okay, and if I had 27 electrons, then it would be neutral, but it's positive. So I must have more positives than I have negatives. So I must have fewer electrons. So 27, 24. So this would be the answer. If I had 30 electrons, then it would have been a -3 charge because I had more negatives. So this has to be answer A. All the following describe a neutron except, so be careful about this except. So it determines the identity of an atom. No, that's the proton. So all of these describe except. So I think that's my answer, A. Let's keep going. It does not carry a charge. That's true. It's located in the nucleus. That's true. And it, along with the proton, makes most of the mass of the atom. That's true. So B, C, and D are true. A is the one that's not true. It's talking about the proton. Which of the following is an isotope of potassium 40? Okay, well, potassium that weighs 40. Okay, and if I look up my potassium, it has 19 on the bottom. Okay, I need somebody else who is also potassium, but not 40. Okay, so potassium 40, that guy is not good, and these, it has to be the same element. So it's potassium 39 is the answer. That they're going to be isotopes. Two things that are the same element with different masses. Those are isotopes. Okay, 20. Which of the following states of matter are the attractive forces between the molecules strongest? Definitely solid. Okay, solid, liquid, then gas, and after gas is plasma. Okay, but solid is the strongest. That's why it holds together, it holds its shape. Which set consists only of elements? So we want to eliminate, okay, these guys will have ions. Okay, we want to eliminate those. Those are compounds. Okay, here's some compounds. Okay, only elements. These are the only ones that are elements. Even though it has a diatomic, that's good. Answer A. What do the elements phosphorus and sulfur have in common? Okay, phosphorus and sulfur. We probably have to look them up on the periodic table, and we'll notice that they are next to each other. Okay, and then chlorine's over here, and silicon's over here, and nitrogen and oxygen. So find them on the periodic table. So, what, are they both alkali metals? No. Alkali metals are way on the other end of the periodic table. They're in the same family? No, because they're next to each other. They are in the same period. Okay, that's the answer. Answer C. And they both form ions? No. S would be 2-, and phosphorus would be a 3- probably. Okay, so answer C is the right answer. 23, but look them up on the periodic table. For the element F on the periodic table, the number 19 represents what? Okay, so if you look up that on the periodic table, right below it, it's going to say 19.00, and above it is a 9. And that 19, it's the average mass of all isotopes of F. I think that's true. Is it the mass number? No. It might be the mass number of one isotope, but not. Is it the number of neutrons? Definitely not. Is it the number of protons? Definitely not. The number of protons is 9. Okay, number of neutrons depends on the isotope, so you can't tell from here. But it is the average of all the different isotopes. And they must, either average out or be mostly 19 to come out that nice whole number. Okay, which of the following is not a typical property of non-metals? Okay, non-metals, which is not a typical property. So we're actually looking for a property of metals. So they are dull in appearance. That is typical. That's not the answer. They are insulators. That's typical. They can be ductile. Okay, ductile means you can draw them into wires. Okay, that's a metal thing. So that's our answer. And they form anions. No, the metals form positive ions. Okay, the these nonmetals, they do form anions. So A, B, and D are typical properties of nonmetals. So they are not the answer. C is a good one. 25. Watch out for these negative type problems. The element sulfur forms an ion with what charge? Okay, we should just know sulfur is 2-. Okay, just from where it is on the periodic table. Okay, you have the noble gases, you got the halogens, you got sulfur over here. So these guys are 0, these are -1, these are -2s. Okay, so just on the periodic table you should know it's answer D. Which of the following names is correctly paired with its formula? Okay, knowing our ions, carbonate, that's good. Okay, that is chlorate, and that says chloride, so that is wrong. Or which is correctly paired? Uh-oh, correctly paired. I almost did it wrong. Okay, so answer A is our correct answer. Okay, let me clean this up a little bit. Okay, carbonate, that is carbonate. That's chlorate, not chloride. That's ferrous, not ferric. And that's nitrite, not nitrate. Anyway, so those are we can eliminate those. Which of the following is a liquid non-metal atom at room temperature? Okay, we're just supposed to know this. Okay, so non-metals are the things way over in the corner, over here, of the periodic table. And we only have two liquids in the whole periodic table. One is a metal, that's mercury, and the other one is bromine, and that's our non-metal. So the non-metal atom at room temperature. Okay, which of the element is diatomic and typically forms a cation with a charge of +1? Okay, so it's diatomic +1. +1 means it's the very first column of the periodic table, and the only one of those are all metals, except for this guy up here, hydrogen. Hydrogen is diatomic, forms +1, answer B. So that's just little tidbits that you know. Okay, the atomic mass of aluminum is 26.98, almost 27. Which of the following is correct? Okay, one atom has a mass of this. No, this is the number, on the periodic table, and it's going to be 26.98, and aluminum is number 13. Okay, well, this is just saying this is the average of all the different isotopes, so it's not one atom does not have that. Okay, one atom has a mass of that many grams. Okay, that's even worse. One atom wouldn't be grams. Okay, 1 mole, okay, now that sounds good, contains 26.98 atoms. No, 1 mole contains 6.02 times 10 to 23. Okay, but 1 mole would have a mass of 26.98 grams. Yes, that's a true statement about 29. Okay, which of the following compounds is ionic? Okay, ionic, somebody starts with a metal, so we can eliminate this one, and this one. Okay, so answer A is the only one that's going to be ionic compound. And double check, it's going to be aluminum 3+, and it's going to be Cl1-, and we're going to need 3 of those, and that comes up later. So answer A. Okay, which of the compounds is incorrectly paired with its type? Incorrectly paired. So if it's correctly paired, we're going to knock it off. So Ca, that's a metal, ionic, that's going to be good. Starts with an H, that's an acid, that's going to be good. Starts with carbon, but we need some hydrogens. So I would say that's the one, that's our answer, C. Let's double check. Phosphorus and sulfur, a couple of non-metals, that'll be covalent. Yeah, so it's this answer here. If I had like CH4, that would be good, but not CS. So that would be a covalent compound. So 31 is C. This compound contains how many atoms of hydrogen? So this is just, can you read this formula? And you say there are NH4, and there's another NH4, and there's a CO3, and these have charges. But we have 1, 2, 3, 4, 5, 6, 7, 8 atoms of hydrogen in that compound. That just, do you know what a formula means? Okay, what is the percent carbon in barium carbonate? Okay, if I were going to figure out barium carbonate, I'd say Ba and a C, an O3, and the carbon weighs 12.01. Okay, and if I go through this and add them all three together, I get 197. So percent carbon would be 12.01 divided by the total, 197.3 times 100. So 12 over 197 times 100. So that is going to be answer B. We'll just have to use our calculator real quick to get that one worked out. Okay? We can sort of eliminate some of the others. It's certainly not 20%, but I would use my calculator. 34. What is the mass of 1 mole of aluminum sulfate? So we look at that formula and say, okay, what have I got? I've got 2 aluminums, and I've got sulfur times 3, sulfate times 3, so I need 3 sulfurs, and I have 3 times 4, I have 12 oxygens. So I'm going to have to do 2 times aluminum, look it up on the periodic table, 26.98. And I have 3 sulfurs, and sulfurs are 32.07. And I have 12 oxygens, and each of those is 16.00. And then I have to just add all that stuff up. So I'm going to kind of round it off because I just need a rough answer. So 2 times 27 would be 54. 3 times 32 would be 96. And 12 times 16, well 10 times 16 would be 160 plus 32, so 192. And if I add all those together, I get answer C, 342. So it's definitely a math problem, but it's, do you know what a formula means, and then can you go through these steps? Okay, which of the following is incorrect? Okay, about mole facts. A mole of oxygen molecule has 6.02 times 10 to the 23 oxygen atoms. No, that's wrong. Okay, it has that many molecules, would have double that number atoms because it's O2. 1 mole of O2 has a mass of 32 grams. That would be true because each oxygen is 16 and there's 2 of them. So I think that's our answer. 1 mole of oxygen molecules occupies 22.4 liters at STP. Okay, well that actually sounds good too. Okay, because a mole of a gas is 22.4 liters. Okay, all of the above statements are correct. No. Okay, so what's wrong here? Oh, what's wrong is that I am missing this word. What is incorrect? Okay, well that's correct. That's correct. Okay, which of the following is incorrect? A is incorrect. And all the following statements are correct. That's actually incorrect also. Okay, but we're going for answer A on that. Okay, so that's the incorrect answer. And again, watch out for those negative questions. Okay, what is the volume of 0.5 moles of carbon dioxide gas at STP? Okay, well that's 0.5 moles, that's half a mole. Well, 1 mole is 22.4 liters, so half a mole would be half that, 11.2 liters. Now officially what I'm doing, I'm saying I got 0.500 moles, and I know that for every 1 mole there's 22.4 liters at STP. So when I multiply 0.5 times 22.4, I get 11.2. Okay, 37. How many moles of cyanide, hydrogen cyanide, are contained in 9 grams of hydrogen cyanide? And it gives us the molar mass, which is great because that's the conversion we need. So we're just going to start 9 grams of HCN. And we know this is a mole problem. It's going to be a conversion. So I want to go from grams. I got grams here. I want grams to moles. And luckily they've done the work for us, okay, HCN, that it's 27.03. Now we can use a calculator, but we can see this. 9 goes in the 9 once, and 9 goes in the 27 3 times. So we're looking for an answer of 1/3, which mathematically would be 0.333, answer A. How many molecules are in 2 times 10 to the minus 2 moles of carbon tetrachloride? Okay, again, here's a mole problem. So we're going to start with our number, 2.00 times 10 to the negative 2 moles. Okay, and we're trying to find how many molecules. So we're going to say for every 1 mole, then we have 6.02 times 10 to the 23 molecules. Okay, now we can sort of do this in our head and say 10 to the minus 2, 10 to the minus 20, 10 to the 23. They're going to add those up. That's going to be 10 to the 21. And 2 times 6 is going to be 12. So 12 times 10 to the 21 would be 1.2 times 10 to the, I just made this smaller so this gets bigger, so it'd be 22. Okay, so 1.2 times 10 to the 22. So that would be answer D. Calculator question. Organic chemistry is a branch of chemistry that is the study of compounds of carbon. Okay, that's that answer. Compounds produced by living organisms. That was the old definition, and they found out they didn't have to have that. Talking about non-metals, there are mostly non-metals, but not necessarily. And once living organisms, no, definitely not. Okay, so it's answer A. What's the bonding capacity of oxygen? Okay, you should just know that oxygen can make 2 bonds. Okay, we have the bonding capacity of the chlorine, bromine, and iodine on the periodic table. Those are 1. Oxygen and sulfur, 2. Nitrogen's 3. Anyway, that's just from when we were building those models. Remember, the red atoms had, 2 holes in it, so it can make 2 bonds. The general formula CnH2n describes the molecular composition of the hydrogen family known as, okay, so the alkanes were 2n plus 2. Okay, the alkenes is the idea. The alkynes is 2n minus 2. And the alkadienes, okay, we're not going to do that. That's, one where you have 2 double bonds. And that would also be 2n minus 2. But that's, we just need 4 answers. So it's an alkene. Structural formulas have advantages over molecular formulas. Okay, structural formulas are when we do this to show, who is, connected to who. Because if I look at this guy and say C2H5OH, or I could just say C2H6O, okay, well, if I told you that, you wouldn't know whether this is the formula or maybe it's, something with a carbons with oxygen between. Anyway, so the bonding arrangement of each carbon atom, geometric arrangement of the atoms, number of atoms of each element present, percent composition. Okay, well, these 2 we can eliminate because those are the same from the other formulas. Bonding arrangement of each carbon, or the geometric arrangement of the atoms. I think B is the best answer. Okay, because we don't just care about the carbons, we care about all the other atoms. So like in this case, is the oxygen here. Okay, this is an alcohol. Okay, where this guy is an ether. And, the geometric arrangement of the atoms makes a difference. So we can get that wording down. Okay, the number of isomers of bromopropane. Okay, bromopropane. So that means 3 carbons. Okay, and instead of one of the hydrogens, we're going to put a bromine. So where can we put it? We could put it here, or here, or here. That would be 1 bromopropane. Here, here, and here. That's all going to be the same. We just flip it over. And then if you put it here or here, that would be different. That would be 2 bromopropane. So there are 2 isomers of bromopropane. Okay, which of the following is an isomer of this guy? So what do we notice? We got a fluorine here, we got a fluorine here, we have a double bond. So this guy is trans. Okay, so we need to have an isomer. So either we could do a cis, okay, or we could do both on the same one, same carbon. So let's see, this fluorine, okay, this would be an isomer of this compound. So answer A is good. This is the same exact thing. This is just, this is trans, just flipped over. Okay, this guy has too many fluorines, so we can eliminate those 2. And this guy doesn't have a double bond, so we can eliminate that one. So the only good answer is this one. So this is trans 1,2-difluoroethane, and this is 1,1-difluoroethene, because of double bond. Okay, 45. How many carbons make up the parent chain of this molecule? So remember, this can go around corners, so we would go as longest chain we could find is 1, 2, 3, 4, 5, 6 carbons in a row. So this guy would be 3,4-dimethyl hexane. 6 is hexane. Got to remember those. Okay, now which is the correct name for the following compound? Okay, so here I'm going to number these as 1, 2, and 3. Okay, and I got 2 bromines on here, and 3 means propane. So this is going to be a 1,1-dibromo propane. 1,1-dibromopropane. There's my answer right there. Answer B. Okay, and this guy here, which functional group is found in the following compound? We got a C double bond O in between other ones. Okay, so it's not an aldehyde, that's a ketone. And that's the right answer. Okay, so 48. Which of these is an ether? Ether is oxygen between 2 other sets of carbons, so that would be answer C. And the structure of which compound is given below? That is an alcohol. Okay, and these are alcohol, so you can do that's an acetone. Forget that one. Okay, and it's got 2 carbons, so it's ethanol, grain alcohol, the kind that people drink. Okay, so I'm going to stop here and I'll have to do the rest of these in a separate file.